This is the DC motor control circuit. The purpose of this circuit was to 1. Change the direction of the motor, 2. Change the speed of the motor, and 3. Have a coast and full stop option for the motor when voltage isn't being applied, and to do it all using the L293D H-bridge IC. To achieve the goals stated in the purpose, all controls are hardware-based. This first button turns the motor clockwise, this second button turns the motor counterclockwise, and this third button makes the motor come to a full stop. If one of the first two buttons are pressed and released but the third button is not pressed, the motor will be put in neutral and will coast. Finally, this potentiometer can adjust the speed while the buttons are pressed, and even when they are not pressed. The Arduino Uno is used as the communicator which reads the hardware inputs and tells the L293D what to output to the motor pins. The DC motor is used in this circuit, spins through a controlled electromagnetic field that pushes the supplied electricity, which powers the spinning coils, of the motor and creates torque. As the coil spins in one direction, it eventually reaches the midpoint of the field and continues to rotate on the opposite side. However, when the coil is near the midpoint, the torque action nears zero, so there is irregular motion as it goes down. This is why many coils are placed within the motor, so that there is always one getting pushed. The direction of the motor depends on which pin is set to high and which is set to low. Using the L293D, this can be controlled and manipulated, as it is with the use of the push buttons and potentiometer. As previously mentioned, the DC motor is controlled by the L293D H-bridge IC. An H-bridge IC is essentially two MOSFETs, or a PNP and NPN transistor, where one is connected to a high voltage bus and the other to a low voltage bus. In order to control the polarity of the voltage applied to the load, the motor is connected to the output pins of this device, which, depending on the hardware input, can set the outputs to high or low at different times, thus controlling the polarity of the voltage, and therefore the direction of the motor. The software that facilitates input-output communication is relatively simple for this circuit. All that happens is a series of if statements that tell the L293D outputs what to do depending on the situation. This is how the buttons are controlled. The potentiometer speed adjustment is also controlled by reading the amount of voltage that the potentiometer is letting through with the analog read pin and applying that to the enable pin in the if statements so that the motor operates at that level of voltage and equivalent speed. And that is how this project, the DC motor control circuit, works. Thanks for watching.